So we're good to go. Hello again, everyone. Welcome. Thank you for joining us today on this webinar on retrofitting and upgrading water and wastewater treatment plants. Before we start, I'd like to note that during the webinar, you can post your questions in the Q&A box. We'll be taking questions in the end for as long as we have time during the webinar, and then all the rest of the questions will be answered by email. So I am Ronan Schechter, a technology consultant with WFI. Very proud to present today the topic and our speakers on the webinar. So I'll be giving a brief intro before we dive in to the technological part. Dana Hubner, our VP Business Development, will follow with a brief overview of WFI Group and its companies. Then we'll have a couple of our technical experts. First will be Noam Perlmutter, speaking about the flow reversal osmosis technology called Rotec. Noam is CEO in Rotec. And then Amir Tzalel will showcase TAIA, a biological wastewater treatment that can be described as reciprocating constructed wetlands. Then we'll go into the Q&A. So without further ado, let's begin with a short intro. So just laying the foundations for what we're talking about today. There are dictionary and Wikipedia definitions for retrofits, but I am guessing that most of us know what it's all about. Basically, improvement of existing systems, usually done by adding or replacing or modifying in some way existing components or adding new components to the system. Retrofits are synonymously called upgrades many times. The projects are often described as brownfield projects as opposed to greenfield projects, which are new projects on bare land. So this is it with the formalities and definitions. So what drives the need for retrofit projects, just as part of the overview? So there's the regulatory requirements for better effluent, for example, lower limits, additional parameters that are regulated. That's one driver by regulation, but there's another mechanism of regulators driving improvements in water and wastewater treatment systems, and that's by incentives given for the type of improvements that the regulator wishes to promote, such as to improve energy efficiency or resource recovery, for example. But there are others, for example, natural growth, which increases the quantity of water that needs to be supplied or wastewater that needs to be treated. Natural processes like urbanization, population growth, or gradual increase in water consumption per capita. And there's a third different one, which is technology development. In this case, it's not a driver that, it's not the need that drives the retrofit. It's more the opportunity and possibility to improve and profit more from the wastewater treatment operation. For example, if a technology for energy efficiency might save more than it costs over the lifetime of the system, that would make sense to install because the technology exists. So that's another type of retrofit. So looking into what the retrofit market is, we can distinguish between markets, developing markets and developed markets in developed countries. So what is the difference there? In developing countries, the water consumption is basically low many times and growing as countries develop. That's a normal process. We'll see some data soon. There's higher growth rate, processes like urbanization that change the requirements from infrastructure. Many times infrastructure is missing and is being created in the course of development. So these markets are generally characterized by new build projects, greenfield projects, and less retrofits because there's less retrofit. In developed countries, things are almost the exact opposite. Water consumption is pretty stable. Sometimes it even decreases in response to incentives to save water, for example. There's slow growth in population and infrastructure is there. It's developed, water is being supplied, a network exists, wastewater treatment is operating. So in these cases, it's mainly retrofitting aging systems and infrastructure and improving on operational parameters such as effluent quality and energy efficiency and others. So in general, I am claiming here that retrofits are more common in developed countries and new build projects are more common in developing countries. And there's some data to support that. So we're seeing that over about 3 decades, water consumption in US and France, which were fully developed practically in the 80s, has not changed by much or not at all. Whereas in China, which has gone through massive development, including infrastructure and probably quality of life for its citizens, we see a very sharp increase in national water consumption, which indicates on the processes that occurred in China in water and the processes that occurred in the United States and France. In the bottom, we see Ethiopia as a pretty flat line, but this is misleading because the consumption there is low. And if we blow up this specific line, we can see that over just 5 years, water consumption has more than doubled in Ethiopia, which is a slope much higher than any 5 years in the growth in water consumption in China that we've seen before. So another fast growing country, economy. So a lot of greenfield projects, and we know that, and probably less retrofit projects. So that was a sort of description of the market, but let's also look at what retrofit projects are. So what characterizes retrofit projects is complicated construction and fewer degrees of freedom in design, because you need to adapt to an existing system and you need to work in a site where a lot of infrastructure and heavy equipment already exists. So that's a complication that is unique to retrofit projects. Also, success criteria are often phrased differently in relative terms to previous performance, such as a % increase in capacity, % improvement in recovery, or % decrease in energy consumption. So measurements are relative to previous systems performance. Another a unique thing for retrofits relative to new builds. The nice thing about retrofits is that there are some unique new concepts that emerge lately. One example that is especially dear to me, so I brought it up here, is the possibility to use decentralized design instead of expansions in some cases where it makes sense. So if we have this situation with a question how to manage wastewater from a new neighborhood, take for example, the one circled here at the top left, how would you manage wastewater treatment from such a plan? So one possibility, okay, sorry for that, is to expand the wastewater treatment plant as seen on the right side, which is bigger from the left one, and drive a lot of piping, wastewater piping, probably pumping, and if you want to do any reuse, so you'd have some effluent piping as well running from the plant. So that's one possibility, very common. I think it's the default design possibility, but lately a new concept is being explored a lot, and that is the local treatment and even reuse when this is possible or required. So we see that this new neighborhood, instead of connecting to a bigger plant, just treats locally and even discharges the effluent for reuse. Of course, this concept is on a case-by-case basis where it makes sense and the profitability. Digging a little bit more into this concept, it has been quantified by several studies. This bar chart shown here is taken from one publication, and there are others, comparing the cost for specific cases, the life cycle cost of different degrees of distribution for wastewater treatment. And we see that in the case analyzed in this work, the distributed solution is actually a much lower cost over the life cycle of the plant relative to the centralized solution. So that's one of the unique opportunities and possibilities in retrofits too. So in a way of a summary of this intro, there are unique possibilities in retrofits. An important note is that, you know, a new build design can be built around any technology, but not every technology can be used for retrofitting. What we're going to do today is showcase a couple of unique technologies, less known than textbook material, but very established already, that are actually suitable for retrofits as well as new builds. And with this summary in mind, I would like to pass the presentation to Dana Hubner, our VP Business Development, who will give a brief intro of WFI. Dana, the floor is yours.
WFI focuses on water and wastewater treatment and reuse. The reason we decided to devote this webinar to the retrofit arena relates to the part that we have a recurring demand for such kind of projects. I would like to provide you a short overview of WFI Group and its business units. WFI is mainly focused on water and wastewater treatment and reuse while providing an economical value to our clients. The solution we provide enhances sustainability and answers stringent regulations demand. Within the group, we have top-notch technologies, proprietary technologies, which are fully developed and deployed worldwide. We have wide spectrum of turnkey solutions. In some cases, we provide design and core elements, and in other kind of projects, we provide the full turnkey project. We provide to our clients financial tools in order to ease the implementation of the project on site. Within the group, we have 60 employees. More than half of them are technical, from scientists, engineers, and project managers. As for the group itself, the group is a privately owned group by a US shareholder. The headquarters is in the US and Israel. We were established a decade ago, and we operate worldwide via strategic partnerships and local entities. Our strategic partnerships are usually either engineering companies or integration companies. All of the technology in the group are approved by recognized bodies. You can see here several examples, such as technology approval for innovation in Belgium, LifeDop approval for OPEX reduction in Italy, and SIWW award within Singapore. You can see in the map presented here the geographical distribution in the group. The recent project we finalized recently is in Mozambique. We generated a 30,000 cubes per day filtration project, and in Malta, a seawater RO generating 11,000 cubes of water a day. Within the group, we have installed capacity of 112 million of cubes per year. And as an independent factor, the wastewater reuse capacity is 83 million cubes a year. Altogether, we provide OPEX savings either by high recovery rate, energy reduction, sludge reduction, and more. The market segments we are operating within are varied. We operate in drinking water sectors, generating high quality of water, answering stringent requirements such as NSF, removing pollutants such as chromium and perchlorate, municipal wastewater, dealing with decentralized communities which are interested to either disconnect or not getting attached to a new centralized wastewater treatment plant, understanding the reuse value of the wastewater. Agriculture wastewater, we're mainly dealing with high total nitrogen removal, for example, in piggeries. And industrial sector varies from mining wastewater, industrial facilities such as electroplating and PCBs, and F&Bs. Within the group, we have 4 business units. 3 out of them are technology, proprietary technologies developed in Israel. Toxob, with a leading technology related to selective removal of inorganic contaminants, generating minimal sludge and minimal chemical consumption. Twimplety, with biological wastewater solutions mainly for decentralized locations, generating 80% lower OPEX comparing to conventional solutions with minimal sludge, minimal labor required. Rotec, with high recovery rate, mainly for breakage water, accelerating the process from 70% to up to 95%. And AST, which is our integration company. Today, we decided to focus mainly on Triple-T and Rotec and to demonstrate also the kind of combinations which is possible between the 2 kinds of solutions. The project types we are dealing with are greenfield, taking the project from the beginning to a turnkey project. It can be an upgrade project where we accelerate the requirements of the effluent, or it can be a retrofit where we provide higher performance to the client, mainly related to OPEX, such as energy, sludge, etc. I would like to demonstrate 2 types of cross-platforms which are available between the solutions in the group. One of them relates to taking biological wastewater and transforming them through a biological wastewater treatment via RO desalination polish. And in this case, we are capable to generate potable water either for industrial reuse and additional uses. Additional flow cross-platform relates to holistical water cycle, meaning that we can take a wastewater, breakage water, and we're using them back to the community twice. In this case, we take the breakage water coming into the facility of an RO, coming into the community, and then going out as a biological wastewater and being reused for agriculture applications. Thank you, and I hope you enjoyed the webinar today.
Thank you, Dana. And following up on Dana, we will dive in to a couple of new, unique technologies, well established though. First one will be Noam Perlmutter, CEO of Rotec, presenting the flow reversal technology for reverse osmosis. Noam, if you could share your presentation, please.
Okay, I hope that worked.
It will work. Here, it's already working.
It's already working. Okay, so thank you very much, Ronen. My name is Noam Perlmutter. I'm the CEO of Rotec. And today I'm going to demonstrate how to do a retrofit on an existing RO system using flow reversal technology. So let's start by dealing with what we are basically providing. Rotec is providing 4 types of solution to the desalination industry. We are providing a super high recovery desalination plant. We also provide brine concentration system. In some cases, we only provide the engineering package needed to build the system. And today we're going to talk about a very unique product or solution, which is retrofitting of an existing RO plant. A little bit about Rotec. We are started in 2009. Today we have more than 50 installations all around the world, and we are active in today more than 15 countries. The technology allows you to increase dramatically the recovery rate in our system, even up to 98% recovery, which translates directly to more product, dramatically less amount of brine, and most important is this technology is 100% proven in the field. What is flow reversal? So basically, flow reversal is taking out the stagnation from the standard RO system. In a standard RO system, when you try to increase the recovery, after a few hours, you will get scaling on, like you see here, on the tail element of the system. And when this happens, you need to stop the system, and it's not a pleasant situation. This is not what happens in flow reversal system. In flow reversal system, when this scaling happens, we are changing the direction of flow across the membranes. And the last membrane, the tail element, is now the first element, and it's exposed to undersaturated solution, so we can dissolve back to the solution the nucleus that start to accumulate on the membrane, and by doing so, we are cleaning the membrane. And this allows us to work at very, very high recovery. In industrial system, when you have more than one stage, at least 2 stages, like you see here, in this case, 2 blocks are in the first stage, and the second block, or the A block, is in the second stage. What we are doing is basically divide the burden of being the last stage of the system between the blocks. And we are doing it by adding to the system an array of pipes and valves. And as you can see here, we are changing continuously the block position, rotation, and also the direction of flow inside the block of the RO pressure vessel. So this is basically flow reversal. We can take this technology and not only build a new system, but we can also apply it to an existing system. And today I would like to talk about a case study that we have done in Singapore in a place called Kranji. As you can see here, we took a 455 cubic meter per hour system, and you can see it here before the retrofit and on the right after the retrofit, and we've been able to increase the recovery from 75 to 90%. So some more details. We are talking about the Kranji facility, which is part of the new water array of plants in Singapore. The total capacity of the entire plant is more than 100,000 cubic meters per day. And what we have taken is one of the units over there, and we retrofitted it. And again, 445 cubic meters per hour, it's a very big one. And we managed to increase the recovery from 75 to 90% recovery, with basically the same amount of CIP frequency like a regular system, a standard system on site. What we have done, you can see here on the top, is the original design of the system. As you can see here, a two-stage RO system. In green, it's the first stage, and in yellow, it's the second stage. And on the bottom, you can see the system after the retrofit. Basically, what we added to the system is some pipes, valves, and some additional pressure vessel, and of course, a control unit. And after the retrofit, the system was basically a three-stage system that can work as following. Basically, as I told you, what we are doing is changing the position of the last stage of the system. So every pressure vessel will serve as the first stage of the system and the third stage of the system, like you see here in red. And this is changing all the time. And by doing so, we are dividing the burden of being the last stage of the system, and we can work at very, very high recoveries. As you can see here, everything was pre-prepared in advance in our workshop. Everything was delivered in an orderly manner to the site. And in the site, it took us about 14 days to complete the entire retrofit, and the system immediately continue working. This is a table that summarizes some operational and parameters before and after the retrofit. I would like to focus on two. The first one is the permeate flow, which you can see it increases dramatically. And the second one is a question that we are asking a lot. What about the electrical consumption of the system? Because you are working at 90% or increasing the recovery. As you can see here, we don't change the specific energy consumption per cubic meter of product, which is great. Everything is translated into money eventually. And for this unit, we showed that the additional income for one unit is more than $700,000 per year, which this translates into an ROI of less than 1.5 years, or about 1.5 years. This project was very successful, and it's now been implemented, this technology, in a much larger facility in Singapore. This is a TUAS project. And in this case, we're talking about a 6,000 cubic meter per hour system, which is a vote of confidence from the water utility that uses this. This is not the only retrofit that we have done. We've done several other projects. I will just touch two of them. The first one is a beverage facility in Spain. We took a system that was working on 75% recovery. As you can see here, we added our pipes and valves, and we increased the recovery to 88% recovery. What is so amazing here is that the system is now working on about 500% saturation of silica, which is unheard of in our industry. The second project that I would like to show is, again, a beverage company, a very famous one. We took a 75% recovery rate system, we upgraded it, retrofitted to 90% recovery. And in this case, as you can see here, the system is working since 2014 for a very long period of time, very, very stable, and it's working. Thank you very much. Ronen, I'm bringing you back the control.
Thank you, Noam. A lot of details and information here. I am sure that everybody would be interested to get more information. I think this is a super cool technology and a perfect example of how the discovery of a scientific principle, in this case, the induction period for scaling, was utilized into a practical benefit for a real full-scale engineered systems. So I hope you like it as much as I do. And next coming up is Amir Salel, the lead engineer in Triple T for the tie-up process. Amir, you can upload your presentation. And the floor is yours.
Thank you, Ronen. Just a second. Let me see. Okay. Hi, everybody. Thank you for the presentations. My name is Amir, head of engineering in Triple T. Triple T is a company designing wastewater treatment plant, mostly based on biological treatment. And the special thing is that we have our unique technology called TAIA. I will talk a little bit about this technology and explain about it to those of you who are not familiar with it. And then I will show some examples for retrofits. So our technology called TAIA was developed especially for decentralized locations. When we were in the early stages of developing it, we thought what would be the special important parts of it. And the first thing when looking at decentralized facilities, we understood that the main problem normally is manpower and professional manpower, which is hard to get in small locations. So we looked for developing a technology which is very easy to operate, and you don't need a professional operator to do so. Another thing is to reduce the cost. This has been achieved through main two ways. One is reducing the cost of aeration, and the second is reducing the cost of sludge treatment, and I will talk about it in the coming slides. So what is TAIA? TAIA comes to replace the aerobic anoxic reactor in conventional wastewater treatment plants. We do it by using passive aeration, meaning instead of having blowers and diffuser to push air into the wastewater to supply oxygen to the bacteria, we expose the bacteria to air. Another thing is, since it's an attached growth reactor, we don't need a settler. And again, less electromechanical equipment, easier to operate the wastewater facility. The last important thing is minimum sludge. We hardly produce secondary sludge, meaning you don't need to treat your sludge every day or every week. Instead of doing so once every few years, you do an operation, wash the gravel, and you restart the system. So to explain a little bit what the TAIA contains, the TAIA, as I said earlier on, replaces the aerobic anoxic biological treatment. So if I look at the full wastewater facility, and it's not demonstrated in this movie, we will have in the inlet of the wastewater treatment plant a 6 millimeter screen, and this will be followed by an anaerobic pond just for settling the TSS. And from this pond, we will overflow to the Taya. The Taya is an earth dug basin, like you can see in this demonstration, about 1.5 to 2 meters deep. We seal it with an HDPE layer, and we put a curtain in the middle to separate the Taya into two parts. A Taya will always be made of two basins, which are connected with some type of canal. In this demonstration, it's a concrete canal, but it can also be a canal made from a high diameter pipe. We put a lot of perforated pipes. Just a second, I'll take the movie a little bit back. We put a lot of perforated pipes on the bottom, and we fill it all up with gravel. In the middle, we put a pumping chamber, which contains 2 propeller pumps and 2 pressure transmitters. Sorry, for a second, I compare such a unit to an activated sludge. Instead of having blowers and diffusers and a settler and DO meters and pumps for WAS and RAS streams, in the Taya, I have only 2 propeller pumps, which are very simple pumps to operate. From a process point of view, how it works. So you can see in this picture that the water level on the far side is high, while the water level in the near side is low. And we will circulate the water between the 2 sides. As the water goes down in one side, air comes between the media and supplies the oxygen to the bacteria. We do it in a smart way, taking advantage of the gravitation. So you can see now one side is filling up, the pump is working. Once it stops, by gravitation, the Taya levels, and then the other pump comes into operation, and these cycles go on and on. A pump is operating, leveling the Taya by gravitation, and then the other pump comes into operation. At the end of the Taya, the effluent overflows to a secondary equalization basin, and from this basin, you can take the effluent to river discharge or to reuse in agriculture, for example. Since we aimed at reducing the OPEX, we achieved it, first of all, by passive aeration. This method of exposing the bacteria to air saves a lot on energy. The second thing is minimum sludge. As I said, you don't need to treat daily the sludge. You don't need all the electrical equipment normally found in wastewater treatment plant to handle the sludge. And the last thing, and I think the most important thing, is minimum operation. You don't need a professional operator. You can see very little electromechanical equipment on site, meaning it's very easy and robust to operate. Now, since this webinar is about retrofit, I'll give 3 examples how we use the Taya technology to retrofit existing wastewater facilities. So this is an example from a site in Israel, which used to have wetland based system. In this example, the client had 7 wetland units, vertical, horizontal, free water, all kinds of wetlands. And we took 2 of his wetlands, number 4 and 5, connected them, and made the tire in operation. You can see here the stages. In the first stage, we cleaned the vegetation. In the second stage, we connected the two wetlands and constructed a pumping chamber in the middle. In the third stage, we put an HDPE layer with our perforated pipe, installed the pump, filled it all up with gravel, and we have a tire ready to operate. You can see in this picture, at one side the water are high, the far side the water are low, just before the equalization. From a client point of view, he reduced the size of his wastewater facility and he benefit from higher effluent qualities. In the next example, I think from my point of view, it's one of the sites I like the most, since it really shows all the benefits of Taya. This is a small site, touristic site called Chana Shayarot. When the owner approached us the first time, he had 40 cubes a day wastewater, and you can understand that such a small location will not have professional manpower to operate a wastewater facility. And if he could get one, it would cost him a lot of money relatively to the low flow he has. We took his system that was based on wetlands, which didn't meet the required effluent quality, and we transformed one of the wetlands into an anaerobic pond, and the other wetland into a Taya system. This guy likes to show his wastewater facility, so he even built this platform where he brings tourists and explain about wastewater treatment. There is no smell on the Taya, so it's really interesting to people to hear and see how wastewater treatment takes place. Few years later, he wanted to expand his capacity, so we increased the height of the Taya by adding another layer of perforated pipes and gravel. And this is on the right side a picture of his upgraded system with the capacity of 60 cubes a day. While these two examples show the advantage of retrofit and taking advantage of existing infrastructure, the last example is about a client that needed to upgrade his effluent qualities. In 2010, regulation in Israel changed, and a lot of wastewater facilities had to increase their effluent quality, especially regarding total nitrogen and ammonia concentration. The owner of this wastewater facility had an activated sludge system. You can see here the aerobic treatment, the settlers, and we suggested he takes one of his existing ponds that he used to store sludge and retrofit it into a Taya. And by doing so, he could benefit with much higher effluent qualities, which he used for irrigate the area around the wastewater facility. This is how his Taya looks close by. Just to sum it all up, the Taya is a unique technology with outstanding results and very high effluent quality. It's very well designed to decentralized location. It's very easy to operate, and it's a perfect match to retrofit lagoons, wetland, and system based on surface aerators. Thank you. Ronen?
Thank you. Yeah, thank you, Amir. Please leave this slide on. Keep sharing your screen. No, in presentation mode. That's better. Thank you. Thank you, Amir. To me, the impressive thing about the Taya is that although the process is pretty intuitive, you understand the principle immediately when you hear it the first time, still the small details of all the engineering around it is what makes the principle a process and a product that we can name as Taya. The big difference is in the small details. Anyway, that's just my opinion and impression. And we now start taking questions that were posted during the webinar. I think that you can still try and post, because even if we don't discuss it here during the webinar, we will reply by email to all messages. So just a second. Sorry. Sorry about this glitch. Anyway, first question we'll start with is one that I have seen repeated a couple of times, and this goes to Noam regarding Rotec. I have 2 or 3 repeats around the general topic, so I will rephrase, and if you ask around this topic, please understand that I am directing all of these together to Noam. There's a few questions here regarding typical costs of a Rotec project. There's a question here also asking about the ROI, which you, I think, have discussed, but you can repeat if someone missed that. Also regarding the cost. Okay, so there's a couple around this. So if you could take that now, please.
Yeah, thank you. Okay, regarding costs. So to do a retrofit in an RO system, it's really a percentage of the cost of building the original cost of the system. So it's very much dependent on type of material, brands, and so on. But you're talking about typically for large systems, about 10% of the original cost of the system. And for smaller system, it can reach even 20% of the total cost of the system. It looks a lot, but it's not, because the return on investment is very, very quick. Sometimes it's even less than a year. In most cases, it's less than 1.5 years. And this is a pure outcome of water cost and also brine disposal cost. By increasing the recovery, you're dramatically increasing the value of brine disposal, and also increase the amount of water that you're producing. So the ROI is very quick.
Okay, so Noam, while your mic is on, let's take the opportunity and maybe also answer the question regarding a typical retrofit project duration, or how long does a retrofit project take?
Okay, for small project, small, I'm talking about 100 cubic meters per hour, maybe 200 cubic meters per hour system. It can take about a week when everything is pre-prepared and you know what you are doing, everything is coordinated. For larger project, it can take about 2 weeks to be on site. And it doesn't mean that you are stopping the production. For example, in the project that we have done in Singapore, it took 2 weeks, but the system was shut down for only 3-4 days, that's it. So it doesn't mean that we'll stop in production for all the duration of the execution of a retrofit project.
Okay, and just to wrap up before I pop a few questions to Amir, there is a couple of technical questions here. So one of them, maybe answer all of them together. One of them is regarding the flow reversal frequency. Is it based on timing, preset cycles, or analytics? And the other, there's a few questions here that I'll rephrase for simplicity regarding the pressure limits of ROTEC. Is it applicable to ultra high pressures or seawater?
Okay, I know.
So it's two topics, if you remember.
Yeah. So I will start with the last one regarding ultra high pressure. This is something that we have the capability of doing so. We are now building a system to do flow reversal in ultra high pressure. And I'm talking about more than pressure that you need for seawater, it's above that. It's quite expensive because you need to use very expensive equipment part and building materials, but it's worth the effort. Regarding the frequency of flow reversal, so we are switching direction of flow every few hours, and it takes about 1 minute to do this block rotation. But again, we are not stopping the production. We are decreasing it a little bit, but we are not stopping production while changing the block. And we are basically doing it by knowing the induction time of the system. This can be decided on site or in a let's say pre-planned pilot that we have done on site, or just to analyze, and this is what we are doing in most cases. We analyze the water, the profile of the anions and cations in the water, and we know what to expect in terms of induction time.
Okay, and Amir, can I bounce a couple of questions to you at once?
Yeah.
So there's a couple here. One of them is asking about the scope of supply of Triple T for ATIA project. What does it include? Including design and everything. So what's the scope? That's one of them. Another is regarding how TIA deals with pollutant fluctuations, and can the frequency, the reciprocating frequency, change to apply variable aerobic anoxic time fractions. So first of all, the scope, and then the frequency in response to fluctuations in quality, in influence.
Yeah, all very interesting questions. The scope of supply, basically we supply the pumping chamber with its pump, with the electricity board. It's a, let's call it a plug and play pumping chamber. The other two important elements is the canal. Today we suggest all our clients that we supply the canal with our special high diameter pipes. Transportation is not expensive as we design it, that they fit into each other while delivering them to site. And the last important component is the perforated pipes at the bottom of the tire. Also for this, we have a solution that enables us to send them as a product. So let's say a client who's looking to do the minimum will only build the tire, do the earthwork, put the HDP layer and some concrete floor in the middle of the basin. And from this point, we will supply the pumping chamber, the canal, the perforated pipes, and the curtain to separate the tire into two parts. We install this, and then the client installs the gravel. So our package can include all these elements. Of course, we will supply the process engineer for the entire wastewater facility. Regarding changes and fluctuation in concentration, so first of all, we have the anaerobic pond before the tire, which levels all kinds of fluctuations issues. And the second thing, it is possible to change the number of cycles of fill and drain. We have about 50% increase that we can, let's say we start to operate the facility at day one. Normally we can increase the cycles by 50%. It's automatically done. So this also gives more air and better treatment if concentrations of influent are higher than expected.
So thank you, Amir. I see we're running into the last couple of minutes of our webinar. So I would like to shoot a last question that we got for Dana regarding WFI group's activity on how we operate globally, and do we license or partner with local companies for the global activity. And with that question, I would like to thank everybody and pass it on to Dana, who will bid you farewell after she replies.
So thank you, Ronen. We do have strategic alliances with partners worldwide, mainly in geographies where we don't have existing entities. We find it as an important factor in order to bring a successful project on ground. We usually work with either engineering companies or integration companies, which also benefit from the engineering and works which needs to be done on site. All in all, regarding the webinar, I would just like to summarize from my side, we truly believe that retrofit is the right way to reutilize existing infrastructure in an economical and sustainable way. And as you saw during the presentations, we have several ways to integrate our technologies into existing facilities, and we would like to hear from you in the future. I would just like to say a side note, it's important to know that we will share the presentations after the webinar. Thank you, and goodbye from my side.
So thank you, everybody. This concludes our webinar for today. Hope it was interesting for you all. And we are, of course, here to correspond on our technologies and opportunities. We will answer all of your questions by email, and we will keep in touch. Please keep in touch with us. Goodbye.
Goodbye.
Bye-bye. Thank you.